The phenomenon in which hot water freezes faster than cold water is known as the Mpemba effect. It is named after Mpemba, a Tanzanian student who discovered this effect in 1963 when he observed that hot water froze faster than cold water in certain conditions. Despite this surprising observation, the exact scientific explanation for this effect is still a subject of debate and study. The Mpemba effect suggests that under specific conditions, hot water can freeze faster than cold water. At first glance, this seems weird because according to basic thermodynamics, hot water must first cool down to the temperature of cold water before it can start freezing. Scientists have proposed several theories to explain this phenomenon, though there is no complete consensus in the scientific community. There are some of the most common explanations. Theory number 1. Greater evaporation in hot water. Hot water evaporates more quickly than cold water. As more water evaporates from the hot water, the overall volume of the water decreases, leaving less water to freeze. This theory suggests that the reduction in the volume of water due to evaporation plays a key role in speeding up the freezing process. Theory number 2. Better heat convection in hot water. When hot water cools down, the process of convection occurs more efficiently. This means that heat is distributed and released more uniformly and quickly from hot water compared to cold water, allowing it to reach freezing temperatures faster. Number 3. Faster surface freezing in hot water. When hot water is exposed to cold air, the surface of the water may cool and freeze faster, forming a thin layer of ice. This surface ice can act as an insulator, preventing further heat loss. In contrast, cold water forms surface ice more slowly, so the overall freezing process takes longer. Theory number 4. Dissolved gases and impurities. Hot water may lose some of its dissolved gases or impurities more quickly due to the higher temperature. These gases can interfere with the freezing process, as water with dissolved gases freezes more slowly. By releasing gases, hot water could potentially freeze faster than cold water. Theory number 5. Nonlinear heat transfer phenomena. In some cases, the Mpemba effect may be due to nonlinear behaviors in heat transfer and other physical changes. For example, differences in the environment, container type, or airflow could affect how hot and cold water behave during cooling, possibly resulting in hot water freezing faster. The Mpemba effect has been the subject of many studies and experiments. Researchers have found mixed results. Some experiments confirmed the effect, while others did not. These inconsistencies can be attributed to experimental conditions such as container material, air circulation, water composition, and environmental temperatures. In 2013, a research team led by scientists from the University of New South Wales in Australia attempts to explain this effect using physical models. They proposed that the difference in the structure of hydrogen bonds in hot and cold water could play a significant role. Hydrogen bonds in hot water are weaker, and changes in these bonds may influence how water freezes. In conclusion, although the Mpemba effect has been observed under certain conditions, it remains a scientific puzzle. Several theories have been put forward, but none have been definitively proven to explain the phenomenon in all cases. Ongoing research continues to explore the exact mechanism behind why and how hot water might freeze faster than cold water.